So we are Domino Health Solutions, and our product is Notorious RGB. Our team is Michaela Hatfield, Amelia Ikuta, Carly Ryan, and Eric Halsband. The mission statement of Domino Health Solutions is to provide innovative products for the enhancement of life experience through biomedical engineering applications. Color blindness is caused by a defect on the X chromosome, and there's no current cure. It affects approximately 7% of the male population. And in the figure on the right, you can see the color wheel as perceived by patients with normal color vision, and then as perceived by patients with protanopia, deuteranopia, and tritanopia, which are defects of the color receptors in the retina. So our product optimizes red and green color perception for patients with photoreceptive deficiencies. This is intended for everyday use and an emphasis on patients with protanopia, which is a type of colloquially known as red-green color blindness. This is a Class 2 and Class 3 biomedical device, which means that it will require pre-market approval from the FDA, and the market segments that this is in optics, optometry, and eye care. The device works by better optimizing the activation levels that red, green, and blue photoreceptors receive. So in patients with protoanomalies, the red photoreceptors activate at lower wavelengths than we would typically expect. And one way that we can improve activation levels of each type of color is by removing the range of overlap between red and green activation. And this will allow for the eye to better sense or perceive tricolor. So on the left, we have the visible spectrum against the activation levels of blue, green, and red, against blue, green, and red photoreceptors in the eye. And then on the right, we have the targeted range that we're going to be removing from light entering the eye so as to help patients better perceive red and green color blindness, but red and green color vision. And we're going to do that by using a dip dye treatment, and then that will apply the bandstop filter to the lens, and this should, again, correct the color deficiencies. So to optimize the amount of dye that we're going to imbue in a contact lens, we ran some mathematical modeling in MATLAB to assess how much dye we could expect to elute into and out of the hydrogel before and after the treatment, and then verified this in ZMAX Optics Studio by assessing what wavelengths of light would be taken in and out from our diffraction block. Then in our physical prototyping, we sought to apply a bandstop filter around 550 nanometers and then assess the dye's potential degradation over a day's exposure to body temperature and time. This was done with 6 experimental groups, and 4 of them received the dip dye treatment. There was a negative and a positive control, both held at room temperature, and then several experimental groups held at body temperature. There were 6 total groups and then 60 total samples. And as you can see, the results that we got from the standard level contact lenses were as expected. Again, absorbance level very low, lots of light passing through them. But in our dyed contact lenses, there was quite a bit of light absorption, around 550 nanometers in wavelength. And we took the range of these bandstop filters from each sample and illustrated them on this figure. On the bottom, you can see the range of the visible light spectrum and the targeted range that we were seeking to remove. And the average filter applied across all 4 groups with the dye treatment was in that targeted range. It did fully cover the targeted range. So for manufacturing purposes, it seemed a very feasible task to complete at home for typical contact lenses. And at the end, including all of the fluid, tray, and end product, we would be looking at about $16 per set of contact lenses for daily use. And in the future, we're considering, altering or varying the amount of dye imbued onto the hydrogel, and then also, as part of the pre-market approval, we'll need to assess the dye interactions with contact lens solution. And to even further utilize this technology, there's potential to imbue the dye in the actual cross-linkings of the polymer, which would remove the issue of the eluting and dyeing process altogether. But that would obviously increase manufacturing costs. So this is something that we'll be looking at further in our product development.